Now we are going to talk about the sides of regular polygons. A regular polygon is a polygon that has all sides equal in length and all angles equal. So we can draw a circle inside of a polygon where each side of the polygon is tangent to the circle. Tangent. I'd like you to make note of this word. What does tangent mean? And let me draw. Tangent means that each side is only touching the circle at one point. So this circle is tangent to 5 different lines because there are 5 sides to this polygon, which is a pentagon. So let's take the radius of the circle and have it touch one of the points where the polygon is tangent to the circle. That's going to be our little r. So we can use this to find the area of any regular pentagon. For a regular polygon, not just pentagons, any polygon. A regular polygon with n sides of length s, an inscribed inner radius r, this little guy is going to be r, side is going to be length s, n is going to be the number of sides. We can use the formula a equals n times s times r divided by 2. We will apply this shortly, but I want to show you the other area formula that we are going to be using as well. So we know that we can put a circle on the inside, but we can also put a circle on the outside. That is called a circumscribed polygon. You don't have to know that term. But now the radius is touching an angle instead of a side. Notice how it is touching the side when the circle is on the inside. It's inscribed. When it's circumscribed, it's touching an angle. When it's touching an angle, we have to use this more complicated formula. A equals 0.25 ns times the square root of 4 times r squared minus s squared. Yikes. Know that you do not have to memorize this formula. Just like all of the other formulas in this unit, this test is completely open note, open book, so you do not have to memorize a thing. If you want to have a cheat sheet on the side to use to write your more complicated formulas, so you don't have to keep looking them up, that's fine too. Let's go ahead and apply what we have just learned. So we want to calculate the area of this regular hexagon. So a hexagon has 6 sides. N equals 6. Our side is 51 inches in length. Our radius is 45 inches. Our area is equal to 6 times 51 times 45 divided by 2. And that comes from our formula from up here because the radius was touching a side, not an angle. So that makes life easier for us for sure. So let's plug that into our calculator. 6 times 51 times 45 divided by 2, 6,885 inches squared. A stop sign has a height of 30 inches and each edge measures 12.5 inches. Find the area of the sign. All right, well, a stop sign is an octagon, so it has 8 sides. Each side is 12.5 inches, but what's the radius? Well, it's telling us that the stop sign has a height of 30 inches, so if we draw the height here, our radius is right in the middle of a stop sign, so that's going to mean that it's going to be half of the height. So our radius is 15. So let's plug that into our formula. A equals 8 times 12.5 times 15 divided by 2. Plug that into the calculator. 8 times 12.5 times 15 divided by 2. We get 750 square inches. Calculate the area of this regular pentagon. Oh boy, now we have the radius touching an angle, so we're going to have to use this nasty formula. So make sure you have it handy because we're definitely going to need it. How many sides does it have? 1, 2, 3, 4, 5, because it's a pentagon, right? So n equals 5. A side equals 8. Our radius, and it's a big R, equals 6.8. We use the big R when the radius is touching the corner. So let's plug it into that formula. A equals, what's that ugly thing? See, I don't even have it memorized. 0.25 ns times the square root of 4 times big R squared minus s squared. Let's double check, make sure we got that right. 0.25 ns times 4 times r squared minus s squared. All right, let's do this. Let's do what's on the outside first. We have 0.25 times 5 times 8 equals 10. So A equals 10 times this ugliness that's inside the square root. So let's figure out what that is. We need 6.8 squared 6.8 squared, there we go, times 4, 184.96. 8 squared is 64, so we'll subtract 64, and we get 120.96. Now we got to take the square root of that and multiply it by 10. And we get about 110 meters squared. So go ahead, work on problem 19. They're going to be pretty much identical to what we just did. You are going to have a couple where they're touching the corner because I figure you could use some more practice with that formula. And we'll come back in the next video and talk about circles.